Hello, everyone, and welcome to our webinar. Our topic today is titled, From Outsider to Insider, an Engineer's Perspective of APA Services. My name is Karen Beatty, and I will serve as moderator for the session. Our speaker, Aleeta Dene, and I both work for APA, the Engineered Wood Association. APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered wood products. In addition to quality verification and product testing, APA conducts research to improve engineered wood construction systems and educates users and specifiers on the product's proper use and potential applications. Before we start today's webinar, I need to cover some housekeeping details. Aleeta's presentation will last about 25 minutes. A handout showing the slides can be found in the GoToWebinar dashboard. To ensure that everyone can hear her clearly, we have muted all participants. We encourage you to submit questions by typing them into the questions pane on the control panel on your screen, and I will be monitoring those throughout the session. We'll have time for some Q&A at the end of the session, and we'll get through as many questions as we can. About an hour after the conclusion of the webinar, an email will be sent to each attendee. It will include two links, one to download your certificate of completion, and second, to complete a short survey to guide our future webinar offerings. Our presenter today is Aleeta Dene, Engineered Wood Specialist for APA based in Los Angeles, California. In her role, Aleeta works with designers, building officials, and builders on the various engineered wood products that are used in buildings today and consults on engineered wood use in construction applications. Aleeta, a licensed professional engineer in the state of California, brings 9 years of structural design experience to APA, having worked for Hobach Lewin, Thornton Tomasetti, and ATI architects and engineers in Pasadena and San Francisco. Aleeta has a wealth of wood design experience, including single-family homes for Habitat for Humanity in Riverside County, a puppy birthing center serving guide dogs for the blind in San Rafael, and several schools in California. She is a graduate of Cal Poly San Luis Obispo with a Bachelor's of Science in Architectural Engineering. For those of you just joining us, welcome to APA's webinar on the topic of an engineer's perspective of APA services. I will now turn the microphone over to our speaker, Aleeta Dene.
Thank you, Karen, and welcome everyone. I joined APA just over a year ago, and it's been an incredible experience so far. Prior to joining APA, I worked on a variety of wood buildings, both new and existing. Today, we're going to talk about a few things I either didn't know or didn't fully appreciate until I came to work at APA. So a little bit about APA. APA is a nonprofit trade association that specifically focuses on engineered wood products. Usually when I talk to people in the field, they may know about one or two of the APA divisions, but very few are familiar with all four. So I'm going to go take you quickly through them, starting with the Market Communications Division, which creates the many publications and web content you may have already seen. Technical services are the kind of super science sauce, developing guidelines and backing it up with testing. This is a photo of some diaphragm testing they perform in the newly expanded testing lab in Tacoma, Washington. Then we have Quality Services, which works with manufacturers to ensure a certified product reaches the construction site. And finally, we have Field Services, which I'm a member of. Our job in Field Services is to connect the dots from manufacturing to the end use, providing education and technical expertise to help get the job done right. Today, we're going to cover some facts and resources available through APA. We'll start by talking a little more about quality services and the testing APA does in our Tacoma lab. We'll also talk about some design tools and options that you may not be aware of, and go over some detailing to help with constructability, and review some guidelines for how to handle a trigger-happy plumber with a Sawzall. APA has a lot of free educational tools, so we'll wrap up by going through a couple different ways for you to stay up to date. APA works in conjunction with ANSI and NIST to develop product standards for engineered wood products. If you're like I was, you reference these in your standards these standards in your general notes and project specifications, but may not pay them much attention. Within APA, technical services is responsible for developing these product standards and testing products, while quality services works with member mills to ensure compliance with the standards during manufacture. The products aren't just used in the US, so APA is accredited by the Standards Council of Canada and the International Accreditation Service. Even though the Technical Service Division in Tacoma does a lot of quality testing, it isn't the only place the products get tested. The Quality Services Division works with each member mill to develop their own in-house quality assurance program, including regular testing and audits. Part of the mill quality program includes performing their own internal inspection on a regular basis. But APA also performs third-party audits at the mill. While I would have expected some type of auditing program of the mill, I didn't expect the mills to have their own labs, which continually test their products. This is an example of a simple bending test and a concentrated load test. Testing at the mill typically isn't as comprehensive as the testing in APA's lab, but it is performed on a regular basis and inspected by APA auditors. I was really surprised to learn that panel products are tested quarterly in the APA Tacoma and Atlanta labs. That's a lot of sheathing tests, especially when you consider that it includes impact load tests of 300 to 400 pounds, concentrated load tests of 400 to 700 pounds spread over a 3-inch diameter disc, and a vacuum pressure soak to test the adhesive bond. One of the reasons the testing is so frequent is because of the high volume of panels produced. I mentioned earlier that technical services backs up their guidelines with testing. APA's Technical Service Division has actually been doing research testing since 1969, but APA recently completed a lab expansion in Tacoma, and the new lab expansion allows for multi-story shear wall testing up to 30 feet tall and full-scale irregular diaphragm testing. When I was last there in January, they were working on testing a new type of shear wall assembly, which was pretty cool. APA research generally centers around wood systems innovations and building code development to advance the capabilities of wood frame construction. Moving on to design tools, the FTAO project is an example of how field services and technical services collaborate to solve a problem identified in the field. One of the tools developed by APA is a free spreadsheet for designing force transfer around openings in shear walls. I used to do this by hand, super tedious. Several engineers I've talked to have created their own spreadsheets, but if you haven't, this tool is ready to go for up to 3 openings and asymmetric piers. The spreadsheet is completely transparent, so you can see all the formulas, even if you can't edit them. The spreadsheet also has a simple design summary section with all the forces you need to pick your hardware and sheathing for your shear wall. So it has the required shear force for your sheathing and the required horizontal strap force and the maximum hold down force you need to design for. The light yellow boxes here highlight the design summary outputs provided by the calculator. The FTAO calculator also determines the shear wall deflection. The deflection is calculated using the 4-term equation seen here and the 3-term equation seen in FIDWIZ. That's the wood lateral design provisions for those who are unfamiliar. Once you've picked the sheathing and hardware to satisfy the forces in the design summary section, you can input them into this section. These sections are separate. So the calculator won't tell you if the sheathing and nailing parameters that you enter in the deflection calculation meet the required sheathing capacity calculated above. So the engineer still needs to check that themselves. But the best part about this calculator is the analysis results fit on 3 pages, and they can be printed directly from Excel or saved as a PDF file. So they're ready to be included in that final calculation package. If you're new to this calculator, we have an intro webinar on our website that goes pretty in depth. Portal frames are another design option that I hadn't previously used in design. I didn't live under a rock, so I'd seen the proprietary shear walls before joining APA. These products were ideal for that front wall of the garage. I hadn't done a lot of residential design though, so I didn't realize that in the residential sector, there's also a site-built option, which is shown on the right. If you detail it correctly, the portal frame acts kind of like a wood moment frame. And the capacity of these walls is based entirely on testing. If you're using the residential code, the portal frame is a great way to add lateral capacity at garage openings. Because the IRC is a prescriptive code, you have to build it exactly the way it's shown in the code. This requires careful attention from your framer. So there's 4 elements you should note in this detail. Number 1 is the header, which extends over the top of the wall and stops just short of the king stud. Number 2 is the strap, installed vertically next to the opening on the opposite side from the sheathing. So if you're sheathing the exterior of your wall, the strap goes on the interior face of your wall. Number 3 is the grid of 8-penny common or box nails in a 3-inch on center pattern at the header. And number 4 is the nailing. 3-inch on center nailing is required at each panel edge and each framing member. APA also has a tech topic on portal frames if you're looking to use this on an engineered wall line. The benefit here is adding lateral capacity at a wall that otherwise might not meet the aspect ratio requirements, while still using regular materials and building it on site. The third design option we're going to talk about today is advanced framing. When I first saw this publication, I thought, advanced? Why are we making it so complicated? This is really about approaching some typical details in a more thoughtful, holistic way, though. Here, we're trying to maximize our envelope energy efficiency, as well as take full advantage of every piece of structure. As an engineer, I typically didn't feel like I had a lot to do with energy performance, but there are several different things that an engineer can do to help. I've highlighted just a few here. So insulating our exterior headers is one, increasing the wall cavity size, or considering insulation when framing corners and wall intersections. These are all pieces that can help your building be more efficient. You can pick and choose which details will work best for your project. For example, you may not be ready to rely on your framer to align the framing so you can use a single top plate, but you may be ready to improve your envelope performance by using insulated headers and corners. Out here in California, the top plates are often getting used as collectors, so the double top plate is doing a lot more work here than it is in other areas of the country. Part of improving envelope performance is making sure that the corners are insulated. I was really used to the detail on the right. Most of the details I've seen go the extra step to consider chip attachment, but don't necessarily consider insulation. Since the insulation is typically installed after the framing has been inspected, details like the one on the right make it impossible to insulate the corner. If we approach this detail a little more thoughtfully, we can help provide a better insulated building. This is another way to get that jip attachment without preventing insulation at the corner. Ladder framing is something I have seen often in specific parts of the Southwest. The detail can be used at most wall intersections. So at an interior wall as shown on the left, or an exterior wall as shown on the right. This is an alternative to the 3-stud California corner shown on the previous slide. While I had never thought about insulation very much, I used to think I had a pretty good handle on framing issues. I think most of us understand that construction sites get wet. Typically, as engineers, we worry more about the in-service moisture condition and less about temporary conditions during construction. I'm sure most of you also realize that wood naturally swells when it gets wet. This can be a big deal on a construction site, especially since the building materials are often stored outside and they're not always protected from the elements. APA-rated panels are required to have a moisture content under 16% when leaving the mill. Typically, the actual moisture content at the time of manufacture is well under 10%. Ideally, you let the panel acclimate before installing, but construction schedules often don't allow for this. As a specifier, there's only so much we can control. Weather, obviously, isn't one of them. We can control the edge nailing and the panel thickness. The thicker the panel, the stronger it is out of plane. This is a picture taken in the San Francisco Bay Area where some panels were buckling up to 3/4 of an inch out of plane. Most drawing sets I've seen specify an 1/8 inch gap. I know I specified an 1/8 inch gap when I was working as an engineer between the panel edges, specifically to prevent this type of buckling. Unfortunately, in this case, the panel growth was restrained by the 2-inch edge nailing. In this case, opting for a thicker panel and a larger nail spacing could have saved the contractor and the project a lot of time. As a designer, sometimes we focus on economizing certain aspects of the project and miss the possible implications on construction. So before specifying the 2-inch edge nailing, maybe check to see if you can use a thicker panel with 4-inch edge nailing. It may save a lot of headaches later. APA has several documents about panel buckling. So if you're anticipating a wet or humid construction site, there are a few different ways each team member can deal with this issue. As an engineer, you can make sure that the nailing you specify still allows for a little panel expansion, or use a thicker panel that will be more resistant to buckling. As a builder, you can get the panels on site early to acclimate before they're installed. And as a framer, you can field nail the panels with the 1/8 inch gaps and then return to finish the nailing right before enclosing a wall. Another place we often see the effects of moisture changes is Gluelamp checking. These are 3 types of checks you might see in the field. They can easily look like delamination from far away. The difference between delamination and checking is the wood fiber pull. So delamination is when the adhesive fails. Seasoning checks mean the wood fibers are pulling apart. This is an example of a side check where the opening is parallel along the side face of the member. If a side check is no greater than 1/3 of the width and 1/3 of the length, you can relax. There shouldn't be a structural concern. APA has a handy flow chart in the owner's guide to understanding checks in glue laminated timber. And this will help you to determine if you need to be worried. If the checks are really large, they can become a structural issue. I definitely saw some fairly large seasoning checks in a couple of the older wood buildings I worked on previous to joining APA. And I wish I'd had this flow chart handy. If the checking of the beams becomes a concern, take a look at this technical note on the evaluation of check size and glue laminated timber beams for some extra information. Now, I'm sure you've all run into a drill happy MEP installer at some point. Sometimes you can help by giving the contractor guidelines up front, but sometimes you don't find out until after the deed is done. For simple span conditions, APA has some helpful graphics showing the areas where the contractor can drill within limits. So for gluelamps, the horizontal holes are limited to one tenth of the depth of the beam or 1 lam depth up to 1.5 inches for Gluelamp, and as long as it's in the center half of the span. They also have a similar document for LVL where they're limiting the hole diameter to 3/4 of an inch for 3.5 inch LVL, up to 1.5 inches for 7.25 inch LVL, and all the way up to 2 inches for any deeper LVL. But these are limited to the middle third of the span. These guides also cover vertical holes. So I've seen this a few times, but they've all been for electrical conduit. So not very large diameter holes typically. This is the strength reduction equation if this comes up on your project. This equation applies to Gluelamp and LVL. Sometimes there isn't really any other place to run the MEP, in which case, hopefully, you get to help locate the holes ahead of time. I came really close to doing this on the Puppy Birthing Center project in San Rafael because they had a very robust HVAC system and a very limited ceiling space. APA recently released guidelines for larger holes, including how to calculate the strength reduction. So this one's for Gluelamp beams, and they have another one for LVL. These are both specifically for horizontally drilled holes. APA has a ton of free resources. So while I knew about some before I joined APA, there were quite a few I wish I had known about. The website's one of the most powerful tools. Not only can you find and download publications, but this is also where you can see upcoming webinars and past webinars on several of the topics we touched on today. There's also a link to a full CAD library with helpful details, like those used for advanced framing and portal frames, which we talked about earlier. All of the resources I mentioned today can be downloaded from the website with free registration. The link here will take you directly to the FTAO webpage where you can download that free calculator we talked about. If you do a lot of residential design, there's also a free wall bracing calculator. And you can sign up to receive monthly APA update newsletters to be notified of future webinars, as well as updates to APA publications and standards. If you sign up for the Designer Circle, you'll receive a quarterly email with technical updates catered specifically for building designers. The YouTube channel is probably the biggest surprise. This is perfect for helping new engineers understand the basics of wood design. There's a lot of topics and videos already loaded on there. The help desk is available every weekday during business hours. They're based in Tacoma, so West Coast hours. And they're a great resource if you've got a quick question. Alternately, you can reach out to your local engineered wood specialist. Your local engineered wood specialist will generally be more familiar with typical design concerns and framing practices in your area, and is available to provide training in person or remotely. This map shows the distribution of engineered wood specialists across North America. You'll note there is one guy in Canada. He's got a really big territory covering Canada. We're all here to help though, and it's free. So definitely reach out if you've got questions or concerns.
Thank you, Aleeta. Some questions came in while you're speaking, and we have a few minutes, so we'll go ahead and answer a few of those. The first, is there an ICC report for portal frames?
Good question. So this has come up a couple times. Portal frames are not proprietary, so they don't require an ICC report. The values shown in the technical topic that we talked about earlier are based on cyclic testing that was used for IRC acceptance.
All right, and I'm just looking through our questions. I going to pick out another lateral one. Does the force transfer on openings, the FTAO calculator, account for dead load?
No, the FTAO calculator doesn't account for any vertical loads. So those loads need to be accounted for separately by the engineer.
Okay, great. And on another calculator question, is the wall bracing calculator also a spreadsheet?
No, the wall bracing calculator isn't a downloaded spreadsheet. The program can be accessed through the APA website, and it's free, but it can't be downloaded.
Excellent. And that's for the residential-based wall bracing provisions.
Right.
Excellent. Okay, and on an advanced framing question, I see, what do you mean by insulated headers?
Okay, so insulated headers refer to headers designed with a width narrower than the wall framing, and that creates an insulation cavity along the length of the header to provide more insulation value.
And what could be used for those insulated headers materials?
In terms of insulation, or in terms of?
I would guess it was the framing was the question.
So definitely here in California, we see a lot of different types of engineered wood beams used there. So a lot of LVL, some Gluelamp, but really any beam that's going to be narrower than your wall can get used there, as long as it works out structurally in your calcs.
Great. And one more, where do you find the vertical hole reduction that you referenced in the slides?
Right, so that's in the field notching and drilling guides. So there's one for Gluelamp beams, which is the S560, and there's one for LVLs, which is the G535 document on the APA website.
Great, and those are the field notching and drilling guides as opposed to the designed ones. Yep. Okay. Thank you so much, Aleeta. Before we conclude, I'd like to touch on 3 quick things related to a short survey, a certificate of completion, and upcoming webinars. We'd really appreciate your feedback. A QR code, as shown here and in the handout, will take you to the survey, or a link will be sent to all registered participants shortly after the webinar ends. We really value your opinions as we plan future webinars, so please take a few minutes to complete this. Also, don't forget to download your certificate of completion from the link in the follow-up email that will be sent to you about an hour after the webinar is over. And make sure that you're signed up to receive our APA update and Designer Circle newsletters that Aleeta noted, so that you'll be notified of our future webinars and updates to APA publications and standards. To receive them, all you need to do, starting from the home page of our website, is to click on Sign In the upper right-hand corner of the page. In the menu that drops down, simply select Register. From there, you'll need to let us know what you'd like to receive, which in this case is the APA update and Designer Circle newsletters. As Aleeta mentioned, if you have technical questions on any topic related to the use of engineered wood products, don't hesitate to contact the APA Help Desk at the address shown here. And Aleeta is just one of the field staff we have throughout the country. These talented people are available to assist design professionals, builders, and code officials. Their individual contact information can be found on our APA website, www.apawood.org. Please feel free to contact each of them and take advantage of this resource. And as mentioned earlier, a recording of today's webinar will be posted at apawood.org in a week or two. And with that, I'd like to thank you all for attending. Have a great day.
Thanks, Karen.